Welcome back everyone. Let's take a look at Theory B from paragraph 8.4. And this part is about the so-called scientific notation. And before we're going to talk what it exactly is, I'm going to give you a showcase why we sometimes like to use it. Because I've typed a number right here, and just to ask you a question, is it now very clear for you how big this number here exactly is? Don't think so, right? I know it's big. It's very big. But I have to count the zeros, and I cannot do that in one go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 3, that are 33 zeros. Okay. But that takes already some time, right? I like it more if I can see in one go how big a number is. And that's where scientific notation can help you a lot. Because powers of 10 we can easily use to evaluate some number. For example, 10 to the 12th power, well, that just means a 1 followed by 12 zeros. For example, 10 to the second power is 100. Yeah, that's a 1 with second zeros. A 10 to the 5th is a 1 with 5 zeros. And this saves me a lot of time when I write this down, and it gives me a better, or at least a quicker, evaluation of how many zeros this number has and how big it actually is. So the amount of zeros is exactly the same as the exponents. Working backwards, if I have a 1 followed by 7 zeros, I can now rewrite that as 10 to the 7th power. So we use powers of 10 to write big numbers shorter and more simply. For example, 800,000, well, that's just the same as 8 times 100,000, right? So now I can say that's the same as 8 times 10 to the 5th power, because this number here is a 1 followed by 5 zeros. So 10 to the 5th power. Not 1 to the 5th power, right? Don't make that mistake. 10 to the 5th power, which means 10 times 10 times 10 times 10 times 10, which gives me 100,000. For example, 15 million is the same as a 1.5 times 10 million, which is the same as 1.5 times 10 to the 7th power. Which means, in this case, if I'm going to now do this times 10 million, I have to move the decimal places. They sometimes introduce you to this. You introduce you to this as this. You move the decimal point 7 spaces to the right, and that means that I first get 15, and then I still have to move it 6 more times. Then I just add 6 zeros. This way of writing numbers is called the scientific notation, de wetenschappelijke notatie, die wellicht niet onverrassend veel wordt gebruikt in de wetenschap. You can write a number in scientific notation without an intermediate step. Here's how to do it. If I have a big number like this, you first write it with all numbers that are not 0 in front times how many times you have to move the decimal place to the right. There are some rules to this. These are the rules. The first number always is between 1 and 10. So for example here, my first number is between 1 and 10. In this case it's 8, so that's okay. Then you follow it up with all the numbers that are not 0. So for example here they use 5 and 3. Here this number is 357. And then you write down times 10, and then the exponent of 10 is how many places I have to move my decimal points. So here it's 7.53 times 10 to the 6th power. Why? I move it 2 spaces to the right, then I have 4 places left, and I go 4 more steps to the right, and then I find my 4 zeros. This is very strange when you first start doing this without proper practice. So I think it's more important to just take a look at the rules. There are some exercises where they just ask you write in scientific notation, or vice versa. If you have a regular notation, if you have a scientific notation, go back to regular notation. A regular notation is just writing it out like this. Just remember, the first number is always between 1 and 10, and the exponent indicates how many places I have to move my decimal point to the right. If I cannot move it anymore to the right, then I add 0. So just to make myself clear, and I have to start up my tablet for you guys, but I gladly do that. Which number would this be right here? Well, it would be 8, and then it would be 3, 5, 7. Sometimes they use commas here, right? Remember, a comma in English mathematics is not a comma in Dutch mathematics, right? This is what we normally use a point for. And then I still have, I've moved it 3 places to the right. 1, 2, 3. So my point would be here. But I still have 5 left. So I have to add 1, 2, 3, 4, 5. Okay. And you see that I made a small mistake here because the comma is not going to be here. Ooh. The comma is going to be right there. Okay, so this comma, like this. Practice this for a bit. I think if you've practiced it enough, in the end, you find what you actually have to do. But check yourself using the answer book, please, because it's very easy to make small minor errors here. For example, this part here. This one is not correct because this number is not between 1 and 10. So this indicates the same number, but this is not a correct scientific notation. Okay, if you have any questions, feel free to ask them during the chat or the lesson. Good luck.